All right, so we got a word problem here. It's about the little boxes you see at Hobby Lobby. An 18 by 22 piece of sheet metal has 4 corners cut out. So originally it's 22 inches by 18 inches. And we cut out 4 corners. And the 4 corners are squares with side lengths of x. So if I cut out 2x's from 22, my length is 22 minus 2x. And if I cut out 2x's from 18, my width is 18 minus 2x. Now when I fold up the edges here and make a box, it looks something like this. And it would be x units tall. My length is 22 minus 2x. My width is 18 minus 2x. And my height is x. Part 2, write an expression in standard form for the volume of the box. So volume is length, width, height. So plugging in, I would have 22 minus 2x times 18 minus 2x, and then I'd have the x. It doesn't really matter what order you use here. We're going to invoke the distributive property. I'm going to 22 both pieces. Until I'm tired, I don't want to do 22 times 18 in my head. 396, so 22 times 18 is 396, minus 44x, and then minus 36x, and then minus, or sorry, not minus, plus 4x squared, because a negative times a negative is positive. There's still this little x floating around, but before I worry about it, I'm going to combine like terms. There's a 4x squared minus 80x plus 396, and I still have to x everything now. And I get my formula for volume as a function of x is 4x cubed minus 80x squared plus 396x. 3 is using your TI-84 to determine a reasonable domain for your function. So we're going to look at the graph. She was 4x cubed minus 80x squared, and then plus 396x. Just zoom 6 it, see what she says. Looks to me like x has to be stuck between 0 and 9. I'm going to play with the window here so we can see more. Well, let's set the y max to be something like 200. We'll go out about 15 units. Go back -5. Look at the graph. Still going to go higher. Set the y max to be 500. Oh. Let's try 800. That's better. Now the reason I'm saying x has to be stuck between 0 and 9 is because this is where volume is positive. This stuff over here happens after the volume dips to be negative. Because like if x was 10, this would be a negative length here. Say x was 15, this would be negative, this would be negative, a negative times a negative is positive, and so forth. So that's kind of why it's behaving that way, but we're stuck between 0 and 9. Obviously, you wouldn't have a box if x was 0. You just have a piece of paper, so there's no brackets. And when x is 9, it wouldn't have width, so no brackets. All right, using your TI-84, determine what value of x creates a box of maximum volume. You're going to hit second trace. You're going to use the maximum function. So second trace maximum, second trace maximum. If you still don't have a TI-84 at home, that's your fault. It says get left, press enter. Get right, press enter. Enter for a guess. I don't know if I can clear that up or not. It's kind of small. She's there. Looks like the x value is about 3.28. And the volume is about 579.36. And that's in cubic inches. It's volume. So that's how you do 15. So you ought to be able to do the one for it, which I don't know where it's at, but it's somewhere. 14. You ought to be able to do 14. And the bell's about to ring, so that's all I can do right now until my planning period.